Hello friends, so today I'm going to explain weekly contest 275. So in this weekly contest we have 5 problems, but I'm going to discuss this second one. So let's go to this problem. So problem says that we have a swap and we have a circular array. So swap is basically to swap the position of two uh, array element. We can say that's two distinct positions. You can pick two distinct positions and swap those positions, value at those positions. And circular array is array in which the last element is adjacent to the first element. So we have given a binary circular array of nums, and we have to return the minimum number of swaps required to group all the one present in the array together at any location. So problem is straightforward. So what it's saying is that we have given a binary array, and so nature of this binary array is circular. So what circle means here is that if I pick this element is adjacent to this first element. So let me open the notepad. Hmm, it's our Microsoft whiteboard. So meanwhile it's opening. So let's discuss this first example test case. So here we can see that we have three ones. So we have to make these one together. So for that we can swap the positions in the array elements, and for example the one is at this place, and if I swap this one with this 0, then all the ones will be together. That's fine. Let's raise this. So this 1 0 1 1 0 0. So this is my array. Now what we have to do is that we have to make all these one together. So for that we can pick any two distinct location and swap the elements of those locations. So in this case I can swap these two elements, and that will make array my all arrays one together. So this required only one swap. Now what we can do that, how we can solve this problem, what will be our approach to solve this problem, what we can do is that, because we need to make all array element together, so for that I can create a window of number of ones in the array element. So in this case we can see that we have 3 ones, so my size of window is 3. So maximum 3 ones can be inside this window, right, to make it together. Now we take this window and start from the location 0 and start counting the number of ones in that location. So once we have number of ones and size, what is the size of our array, so we can minus the number of ones from the size of array, and whatever left is, or we can say that zeros, so that zeros can be swapped with other ones. So in this case, for example, if I take these 3 elements, so we have only 1 1 here, and we have 2 zeros, so we need 2 swaps. So I can take this one at this position and this one at this position. So this need 2 swaps. Now I shift my window one position. Now I'm at this place, and in this case you can see that there is one more added in this window, and number of zeros is only 1. So in this case I need only one swap. So I will move further. So in this case one more 1 is added. So minimum swap needed is 0 because all the ones are together. So same way we can move window one by one, and if we found that the element which we are adding into the window is 1, then we will increase the number of counts in the window by 1, and if element that is leaving from the window is 1, then we can decrease the count by 1. So in this case same way we can keep moving this window one by one, and because array is circular, so we can go up to n plus size of window percentage, or consider the modulus n. So in this way we can cover the circular array also. And the final answer would be the maximum number of ones that we have found in array subarray by moving this subarray one by one minus the size of the subarray. So answer would be size minus maximum ones count in any array. So that will be our answer. So let's jump to the solution. So here you can see that I am just counting the number of ones, so that will be my size or window size or sliding window, you can say that. If number 1 is less than equal to 1, the answer will be always 0 as obvious. Then I will count number of ones in my initial window, and that will be, for example, I will keep that as a maximum 1 in that window. After that I will start iterating one by one, or I will keep iterating my window one by one, and just keep removing the count, which is number of ones, if the element that is just going out of the window is 1, then I will remove the count of 1 by 1, and if element that is cutting into window is equal to 1, then I will increase the count of 1 by 1. And after that I will keep finding the maximum 1 in the sliding window, and after that, once this iteration is done, then I will just subtract that maximum 1 from the size of the window, and that would be my answer. So hope you guys like this solution. If you like the solution, comment, share and subscribe my channel. Thank you for watching.